Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about SLS Green Run. So let's dive right into it. Well, first we have to understand what exactly we are talking about. We are talking about Space Launch System core stage. Basically, Space Launch System have two core aspects on the stage one, that is one this liquid system, and two solid booster. Solid booster have been made by another company and that has already been tested. Everything is green, everything is go to there. So now they are testing the core stage. Now core stage is basically has two propellant. One is oxygen, another is hydrogen, and the interesting part about this is that this is actual flight hardware. Basically they are not going to be like, okay, we tested it, now scrap it, let's make a new one. No, this is quote unquote almost like how SpaceX does a pre-flight test. Is almost like that. Static fire, pardon me, static fire. So it's almost like a static fire. How and this puppy has all four engines. Basically this is final configuration. Basically the hope for this is that they're gonna launch it, they're gonna test this puppy and then send it to moon. And yes, they're supposed to actually go to the moon, as in orbit around the moon in unmanned configuration. They're not gonna send this puppy only to low earth orbit around the, again, stage one will of course fall into the earth, but you get the point. Like this is a complete mission duration that they have to do. So the engine's supposed to go through 8 minutes of complete testing. Now these are RS-25 engines and those are designed to be reusable, so they can go through that kind of abuse. So what happened? This puppy was tested in location B2 test stand. Now B2 test stand is a granddaddy of test stand simply because it was built for Apollo era. So if Apollo era simply means huge, so this stand is so huge it makes SLS looks like a toy. So at 5:27 p.m. Saturday 17 January 2021 they started the engine. Now engine went to full throttle, as in 108%. Now that may sound odd to many people, but think of it this way. Space shuttle engines were evolved, fine-tuned, refined over their whole duration. So they reached a point where they were getting at least 8% more power out of it. Now here's the deal. Do you recalibrate the whole flight software for that kind of a new granular scale, or you just like, okay, engine can now scale up to 108%. So they went that route. That's why 108, it's not like more than 100% efficient. It simply means the throttle value, computer is like, the core logics has not been tampered with. It's just like, hey, do I need more than 100%? I need more than 100%. Okay, I have the throttle that can go up to 108%. So it's just a programming hoo-ha. Do not expect something too much about it. It's just programming hoo-ha. So it did that before the gimbal testing. So the idea was the engine will go full force, and once they stabilize, once they run it for around 60-70 seconds, they will start the hydraulic system, and then they're gonna do the gimbal testing. And before that happens, the safe shutdown of engine happens. Safe shutdown as in nothing caught on fire, nothing went to boom. It was safe, completely safe. However, why the heck that happened? So the total burn time they got is 76 seconds. Not insignificant, but their aim was 8 minutes, which is 480 seconds. So something oopsie happened here. Now be mindful, those of people who have watched the live stream, they would have heard this call out, major component failure, or MCF. Now it does not make any sense at this point in time, simply because rocket shut down successfully and nothing boom happened. So people are like, oh, and there was no engine fire also, so fundamentally it does not make sense. And SLS itself initiated the shutdown. It was not emergency shutdown was from outside. There was no abort sent to it. It was like it has engine controller was talking to the main controller, and main controller is like, something is wrong, let's shut it down. So at this point in time, while I'm making this video, I do make videos in advance, so I do apologize if data is getting outdated. Is that at this point all analysis is showing that this system happened, this fault happened simply because of software malfunction. Now how NASA is saying that is that boundary conditions were set too tight. Think of it this way: if you send your engine command, hey, can you produce, let's say engine turbo pump, can you produce 29,000 rpm, you'll be like, okay, but in realistically speaking, you will never expect 29,000 rpm. You'll always have like 2% or 3% range, quote unquote. Like, and if computer is, if you're inside that, that's good. It's like, it's only gonna trigger something, hey, like you are outside of the expected range and you are like only 50%, then it's like supposed to do a trigger abort systems. But that did not happen here. It was like everything is there. So that's what they are saying, they are too conservative. Basically it was like, if hydraulic oil, which is apparently the culprit here, is like the level is here, the engine can easily work. Like there is redundancy built into the system, so even if you have leakage, fault, or things of that nature, it should still work. So it could keep working till this position, and the hydraulic fuel went a little bit later, and it's like triggered the abort, which should not happen. It should have at least waited till 50% mark. So there was a serious software programming issue, so to say, because again, nobody knows what exactly happened at this point of time, where they're like, okay, this triggered this event, that is not known. Something happened and parameter was not set. Now question is, were they aiming for that? Now NASA, after the abort system, they are talking like that they were aiming for that. Although we have set it conservatively because it's a flight hardware, but now it creates a, paradox loop. It's like, if this is actually flight hardware, you want to test it to 100%. You do not want to be like baby it. Like that's the worst thing you can do, this to think is like, baby it is like, why the heck that happened? So there, at this point in time, all hardware says is like, yeah, okay, we good, hardware is good, solid, and all those issues at the software point. Now this puts NASA in a very, very complex position, simply because each fuel tank, while it has to go through cryogenic stress, because think of it this way, our atmosphere, even at coldest point, is not going to be cold enough to compare to liquid hydrogen and liquid oxygen. So it does put under tank under a lot of stress when you are filling them up completely, and it has already been done once already. So at this point in time, this tank has already gone through 2 cycling, and each tank is only rated for 9 cycling. Basically it has 9 life, so to say. So at this point in time, if they risk another testing, so that will reduce 1 life, so that gives you only few life left. Now you may be like, okay, this is not a reusable system, so what's the problem here? Problem is that puts you way too close. You never want to launch a main mission when you have only 1 life. That's like you're pushing it too close to red line. Now another aspect is, they're generally done in such a way that you have many lives left. So if you have to do launch abort, basically you are on launch pad, weather is like, nope, that happens. That's a common thing that happens, and that's the primary reason why these tanks have that many lives. It's like weather alone can be like, nope, nope, nope. Okay, finally, that has happened in past. So this is a very serious reason why these tanks technically are overbuilt, but still have a life counter where they're like, everybody has to actually count for that. Is, hey, like, dude, try not to put humans in the last life. So that's a issue with them. And this is a flight hardware, so they actually wanted to test where they could have actually that issue of like, hey, weather is not allowing us, or we have to delay launch, or some other fault happens. So having that 9 lives already chewed through, it's a dicey proposition. And the moment they try to do that, that will push the launch. And at this point in time, because it's unmanned, so it does not have flight restriction. The fact is that there's supposed to be a manned system, and everything else is already being built. Like the solid booster, it's already being built at this point in time. The Orion capsule already being assembled at this point in time. Like, as everything is coming together, so if they delay the core stage, that will scrap the whole project, and solid boosters have to be detached again. Like all the segments have to be detached again. So fundamentally, if they do that, there is a very good chance they will push the launch from 2021 unmanned flight throughout the moon to 2022 at best case scenario. So this is puts NASA in a very iffy situation. Now again, let's say they do thorough analysis, they go deep in the every single manual, every single protocol, and they find out, hey dude, some programmer messed up this part. That's it. Like, if they are absolutely damn sure with the data analysis and all the testing, it's like, dude, only this factor was the mess up. It has happened in the past where, like, if somebody would have fixed that programming error, that mission would have been successful. If they are in that position, they might avoid the second system because they do not want to drain the life of this system. So NASA is in a bad position at this point in time. Now Boeing is in worst position simply because SLS is not looking good. Flat out, SLS is not looking good. Like, this should not have taken this long. There is no reason for it. There is no justification for it. It's just like, lol, what else you gonna do? Like, it's almost that kind of scenario. And given how slow SLS is progressing, there is a very serious risk, like as in tangible risk. Now again, Elon Musk timeline never happens, and you have to double the timeline. But at the speed of SpaceX, there is a very serious chance that SLS might become human rated before SLS. I'm saying Starship might become human rated before SLS is done. So that is fundamentally very bad looking for SLS. It's like, that's just not acceptable, and that's what the whole point of SLS. It's like, dude, it's just the same thing. Everything is same from shuttle era. It's like, it should be plug and play, but it's like it's taking longer than shuttle development, and I'm talking about original shuttle development. So it's like, what the hell? And similar issue where everything is working, a rocket is good, everything is fine, no boom event happened, everything is good, but somehow your software messed it up. That has happened with Starliner earlier this year. So this year, I'm sorry, pardon me, last year. And that was the exact same issue. It should have docked with ISS. Everything should have been like easy, comfortable, green, go, but that did not happen. And that's the worst part. Like, not the worst part is that this had a software issue, is the fact that the moment they detected the software issue, that should have triggered basically what you call chain system-wide re-evaluation. That happens in every avionics company. It's like if they detect a fault, it's like, okay, make sure everything else that is dealing with high value hardware or dealing with people's life, double check it, quadruple check it, and it happens. Like that's why you see whenever there is an issue with even rockets that have been flying for 70 years and they have an issue, they ground everything else. That's the whole point of it. It's like, okay, double check, make sure that fault never randomly happens in something else. So Boeing at this point in time should have been like, okay, that's the one thing that should not fail under Boeing is that software issue, because they have learned the hard way. Like software can still fail. So somehow having two software failures year apart, that takes them from a loss of confidence, which NASA had previously, to loss of competence. Can you not program it anymore? It's like, that's a very serious thing, because that's the whole thing, because Starliner should have taught them. It's like, hey, we have to tell, like, maybe let's say they were getting a bit too cocky, bit too confident. They're like, dude, we programmed it, it's gonna work. Let's just say that happens. Like, they are human, they're like me, they're like you, they're human, they make mistake. But point is, once you actually saw the consequence of that mistake, it should have been thoroughly taken care of. Because the moment NASA looked into this, is like, dude, you need to bug fix at least 80 things, not one thing, 80 things. So at that point in time, which happened last year, they should have been like, no, we're gonna quadruple check everything we do, and that did not happen. So that puts Boeing in a really bad position. Now, consequence of that is that people will directly affects what NASA does. That's why Apollo project was cancelled. It's a normal thing. It's like if people are not interested in the system, the project might be cancelled. So SLS in that position already, simply because of the delay. It's like, dude, it should have been easy. It should have been like plug and play. Hey, just redesign the second stage, done, go home. But it's taking so long. And not to mention, there is a serious will from people's side is, hey, make SpaceX the primary contractor. But problem with that, that's the same monopoly that got NASA grounded in the first place. Space shuttle was a single mission. If SpaceX becomes that, no matter how good they are still a monopoly. You never want that, and that's the philosophy moving forward. It's like, no matter what happens, never have a monopoly. It's like, that's the whole reason why we have Dragon. That's the whole reason basically Boeing Starliner Sting being developed, simply because, okay, it's at least 90% done, let's fix it, let's get it going. So no matter what happens, like, again, if a fault condition is developed with Dragon capsule, we can have safely still possess the human launching capabilities. And that's why SLS is being developed also. So no matter what happens, there should always be more than one option. But again, if SLS is becoming ludicrously expensive, ludicrously disappointed, ludicrously delayed, and it's like, and if the moment people start seeing, let's say, actual launches of let's say Starship, like, how the heck you're gonna justify that? It's like, how the heck you're gonna justify burning billions and billions and billions of dollars? How the heck you're gonna justify? Like, people could not justify moon missions. How the heck you're gonna justify burning billions of dollars on SLS? It's like, Senate is not magical thing. Like, again, there is a lag period here, but not infinite lag. So if people lose enough interest, we might be for a rough ride. Like, we might be in a very rough position for Boeing. So this was my presentation on SLS hot fire test fire. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.